Hi, I'm Steve Wetzel.
I'm Kevin Wall.
And I'm Mark Dulick.
And we're going to be showing you the difference proper cable and termination can make in a VFD installation. Here we have our cable, our VFD demo suitcase, an oscilloscope, and a splice box. Kevin, tell us a little bit about the demo.
Absolutely. Our demo contains a 1/2 horsepower VFD and a motor. And what we've done is we've grounded the shaft of the motor, and we'll measure the current flowing to ground using this current probe here.
And in the junction box, we will demonstrate various splicing methods on various cables and see how the shaft current is affected.
First, let's look at the most common type of installation. We've installed 20 feet of unshielded cable from the drive to the box, and then another 5 feet of unshielded cable from the box to the motor. Let's turn on the drive and show you the motor shaft current. As you can see, there are significant current spikes flowing from the motor shaft to the ground. Now let's install VFD cable. First, we are going to do the install like we've seen many times in the field. We will install 20 feet of VFD cable from the drive to the box, and then 5 feet of unshielded cable from the box to the motor. Some industry experts believe that shielded cable is not necessary for short runs. So let's turn on the drive again. And we see virtually no difference. We still have significant current flowing from the motor shaft to ground. We've now put VFD cable on both sides of the box. Turning on the drive shows no improvement. What's going on? This is where proper shield termination plays a role. For shielded cable to be effective, the cable shield must be continuous and isolated from building steel between the drive and the motor. Intermediate terminations, like disconnects or junction boxes, break the cable shield. With a broken shield, this cable performs no better than unshielded cable. So let's bond the shield. The noise we are seeing is high frequency noise, in the order of tens of megahertz. At high frequency, drain wires look like high impedance paths for the current. One application note by a drive manufacturer points out that an inch of drain wire has as much impedance as 250 feet of cable shield at just 1 megahertz. To reduce the impedance of our shield, we need to use a large surface area connection. Let's connect the cable shields together. We'll remove the foil, cut the drain wires, weave the conductors through the shield, and pull the conductors through. Next, we will flatten the cable shield. We don't want to create a pigtail, as that will have less surface area. We will now bond the two flattened cable shields together using a split bolt connector. Split bolt connectors will also work with copper tape shielded cable. Just attach Southwire's termination kit to each cable and bond the shields with the split bolt. Now, we see real improvement. We've taken our ground spike magnitude down by over 80% by properly terminating the shield. This method works for both disconnects and splice boxes. Another method of bonding shields in a box is using a product from BAKC. It allows for quick bonding of the shield via this shield plate adapter that is inside the disconnect. It's available in various sizes and in both plastic and metal.